I'm Sarah Jensen, Technical Editor of Power and Motion, and today I'll be speaking with Kimmo Rauma, Vice President of Danfoss's Editron division, about the company's recent development of a fully electric wheel loader proof of concept vehicle. Could you maybe provide a little bit of an overview then of the electric power system, or what were the components that you guys utilized to ensure fully electric operation?
Yes. And what we started, let's start from the traction side. So from the traction side, as I thought, it was a hydraulic driven traction. So what we changed there was that we took everything, basically what was originally, we took everything out, and then we put there a gearbox and put there one electric motor, which has a continuous and peak power higher than the original hydraulic system has. So we can have more power there. So now we had there one electric motor and a drive system for that, and the mechanical systems. And because there was non-ready gearbox available, we needed to partner with the gearbox manufacturer to be actually able to put that kind of box in there, which was a little bit going more than the extra mile, because we don't manufacture and sell mechanical transmission, but we wanted to make really sure that we can showcase what is possible when you took this step. So now we had basically the traction there. Then for sure we needed to measure that how much energy we need, that we can do the whole day work as we could do in a shift. For sure for sure ICE is going long hours, but the important point is that the operator can work the full shift and then it can be charged. So we need to calculate how much energy actually we need to have in the battery. So we need to have the battery system, and then the energy to DC-DC converters that gives the energy to the traction system. So now we basically could drive the wheel loader as full electric system, and it was functional. But we still have all the work functions, and then we have the cooling systems, then we have the steering systems. All of this can be rethinked at the same time. So the steering system, we decided to go to optimize that, as we now have the electric power available. So we utilized clearly more powerful but less energy using steering system on that. Then we also took the cooling system, the fan systems that were driven directly from the ICE mechanically. We took those and put those running with the electric fans, so that we can actually control them at the same time that the machine, because they are quite heavy power users, and if you don't need them to run full, then you shouldn't run them and save the power. The last part is of course the hydraulic work functions, and there you can nowadays do a lot of things. But because that's then coming a little bit more to hydraulics, we decided that we will first keep the hydraulics as it was and only drive the same hydraulic system with the electric motor and a pump, so that we can at least take it as a parallel system from the main system. And this gives us the flexibility that now you can run the hydraulics for the work functions when you actually need it, and you don't need to run it when you don't need it. And also at the same time, of course, you can shut down, and you will shut down the traction when you are driving so it saves huge amount of power compared that the traditional systems, hydraulic systems, are running the whole system all the time. Even they are closed loop circuits that is flowing, but still you have the losses of the hosing and piping and all of this. So regardless, it gives you a huge energy saving. So those were the main systems.
So you were bringing up before about the hydraulic system and some of the efficiency improvements that were achieved through the conversion. Were there any other benefits or other design impacts to the hydraulic system as you guys were working on the wheel loader?
Yeah, the wheel loader as a total uses half of the energy than before, and it can operate more let's say production efficient. So it's much more efficient, so we get more work done with half of the energy than before. And on top of that, it's silent. and really good for the operator because it's so smooth and easy to drive. So it has all the benefits that that one could have. Of course, the question comes obviously, how about the battery? It's so expensive. How much there was energy there? We use 21 kilowatt hours of battery, which is good to operate for that kind of work that we were doing. And for that, it's also quite cost efficient. It's surprisingly easily to payback time. The question is, of course, that this is then the actual OEMs to decide what kind of hours or operating hours they would provide. But without the question, this is a feasible machine already now to bring to the market, and we have all the knowledge now, and we are free willingly okay to give it to the OEMs, of course, because we want our equipment to be used in the future machines, right. and that's the part. But the efficiency is super good on the machine, and also the how productive it is. It's faster, it has more power also now to the, even we have the same hydraulic circuit on the work functions, but because we have taken the hoses and we have put the electric motor really close to the with the pump to the actual operation, and we get the torque, so we get the fluid to really have the power there immediately. It has more power with the same circuit than before, and it's faster to operate, which is quite fantastic in the consideration that we didn't change the original parts on that. We just are driving the hydraulic circuit with our own pump and our electric motor.
Okay. So do you guys, maybe from this or other types of projects, do you foresee there are benefits for hydraulic systems as machines become more electrified and improving the efficiency or other aspects of the hydraulic system?
Yeah, I think that there will be a lot of changes in the hydraulic systems, and the main question, which is not yet decided, is that should we have a centralized hydraulics? So, and there we have in Danfoss we have a DDP, which is digital displacement pump, and this technology is fascinating because basically you can have 3 pumps in one. So there's one pump which has 3 outlets. And when we run this with electric motor, it's really a modern way of running, making fast electrification of, and then at the same time having only one hydraulic pump and run all the functions of hydraulics. And you don't need to have valves in there because the pump is directly controlling each output. And this is so-called centralized hydraulics. And then from this one pump, you get the hoses to each actuator. And then it's a let's say one way of doing it. The second way is that you make a decentralized hydraulics, which is called zonal hydraulics. And then you put an independent motor and a pump for each actuator close to the actuator circuit, which gives you the benefit that you have a really short hosing, and you have only the hydraulics that is needed for that function. And also you can then stop that function when you don't need it. It doesn't use any energy because it's independent from all other functions. And this zonal hydraulics is also interesting and gives you benefits on the efficiency when you don't need the hoses. And also it takes the valves out because you don't need them, as the electric motor is controlling the work function for that area, and it's not based on the valves. So in both of these, the valves are gone, and you have a much more faster and direct control of the actual end actuators that you have there. And this is not yet, let's say, decided. Nobody is knowing that which one is the better for which kind of application. And super fascinating. And we are building ourselves now different kind of machines and starting to compare. As we are a world leader in hydraulics, we certainly want to be the world leader, and we will be a world leader for the electric hydraulics. But we want to offer the customers the variety, that who wants to go with the DDP with central hydraulics, we have the solutions for that. And we also can go with the general hydraulics, so you can have one electric motor and pump together and place it near to the actuators and use that. But it's a really fascinating because it changes the quite old standard way of a known way of doing hydraulics to the really new era, and gives also a lot of opportunities to the universities and everyone else to make research that what you can actually do. One other thing that is changing is for sure, electric motor can run much more faster in RPMs than an ICE can. So what kind of hydraulic pump would you do if you run it with 10,000 RPMs? Is that feasible or not feasible? Because it becomes really small and fast, but then it's a difficulty with the hydraulic oils. So it's a really interesting, it opens totally new kind of optimization for these areas. And I think that we will see a lot of new things coming up in this era. So hydraulics will live together with electrification and will become much more stronger with it.
Well, that's great to hear that, there's still opportunities for hydraulics, and even as electrification is progressing.